connectivity map. Let's see whether it have completed or not. So F5, oh, completed, yay! Okay, then we can select this. Okay, now, oops, sorry. Now you can select this, then you can actually view it as there's few version that you can look at. I will straight away go to the detail list. So I'm not sure what this is. I haven't used this new version before. So hopefully it gives you like the list that we saw it previously. Okay, what do we have here? Mm, patient time compounds, nothing, nothing, nothing. Okay. Oh, got something. Okay, it was loading. Okay, not too bad, not too bad. Okay, so this is the cell. Okay, so if I look at just a compound, okay. Oh, they give you. Oh, this is very helpful actually, because it's give you straight away what is a class that is already there. So in the previous version, they don't give you that. You have to actually search all of it. Now you see that. Okay. Your score. So the subtype 1 gene signature is actually positively associated with all these genes here. I mean all these compounds that give you the same gene signature. But again, we want to reverse it, so that's why we will scroll all the way down to the negative. The more negative it is, the better it is. So in this case here, your okay, your the highest negative or inverse correlation with the gene signature that you input is actually 2-amino purine, and then you go all the way up like this. Okay, so now that's quite interesting. These are kinase inhibitors that we know that it used in tumors. I mean in cancer treatment. Oops, sorry. So, and then some of the odd one estrogen receptor agonist. So it came out to be that as well. So glucocorticoid. So yeah, so these are some of the lists that you can look at carefully. Okay, so now, okay, again hashtag. Now again, there are many ways that you can identify or prioritize what drugs you want to test. You can choose the top, you know, oh, sorry. You can choose the the top, 3 to 5 to look at it, or you can choose uh, a few of the class that are similar to it. So you can actually export this data out if you want to. Okay, then it will give you all the data here. And when you paste it in, so you can get all the data into Excel if you want to, right? So then you can choose, uh, look at it more carefully. What are all these drugs doing? Okay, so that's one good thing to look at it. Now, of course, if you base on that, it's still a little bit speculative. Now, that is where if you can uh, compare it slightly differently with, okay, if that's the good thing about the connectivity map is that it now also include the gene knockdown uh, data. The gene knockdown is basically they switch off or they silence or knock down each gene at a time and to see what are the other genes that are affected by it. So, for example, okay, if you want to be sure, okay, let's say for example, okay, let's say if you look at the compound list, one of it is the, one of it is the okay, trifostin AG1295 is actually a PDGFR receptor inhibitors. Okay, now if that is true, that inhibiting PDGFR could actually reverse the gene signature of your subtype 1. So then the question then If you look at the gene knockout, then the PDGFR, hopefully it will be there. If it is there, then it indicates a strong signal that most likely inhibiting that it will work. So that's how you're comparing two data sets to be more certain. If two data sets confirm the same conclusion, you are more safer than based on just one data set, right? So if I include this gene knockdown data, so let's see, what do I get? PDGFR. Is it there? Where? This is an inhibitors, but what about the gene? Okay, so just I can actually search. Wow, that's very good. PDGFR. So there's PDGFR1 and 2. So in this case here, if you knock down the two genes, okay, the PDGFR doesn't actually change so much. So which make you think, you know, whether the effect that it is okay, whether the effect that you see is it because it is unique to a particular drug, or whether it is unique for a particular target. It's two different things, right? Even though the small inhibitors, they have a specific target, but again, there are always something the drugs can do, the non-target effect. Okay, so that will help you to actually uh, streamline which one do you want to prioritize to look at first. So again, okay, if I want to go back to try to look at your compounds again, what else is here? Tubulin, PKC, HSP, maybe. There are many HSP though. Let's say HDAC1 selective. Okay, so now one of the compounds that come out is actually this compound called the HDAC1 selective, which is a HDAC inhibitor. So to cross-check this, I want to see whether the knockdown of the HDAC1 also come up in the hit as well. So I'm going to search HDAC1. So again, well, not so much. Okay, so you probably have to try and error many times on all this. Okay, if you come across one that are consistently indicating, you know, a negative score for the compound and also negative score for the for the knockdown, then you are pretty safe to use, you know, to 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 prioritize that and go into the testing. Okay, but of course, this is for specific inhibition. Or if you want, all you can do is you can straight away go into the gene knockdown, and then you can look at. Oops. So if you go to the gene knockdown, you can straight away look at what are the ones that are most prominent, zinc finger, CASK. So these are the genes that when you knock down that give you the reverse signature it is. But of course, not all these genes actually have a compound that could target it. Okay, so compounds most of the time they will have multiple targets. So if it is multiple target and can reverse your gene signature, it is something worth looking at. For gene knockdown, normally we are knocking down or silence a specific gene at a time. So it is very specific. Compound is less specific compared to knockdown. So when you combine these two data sets, it will give you a quite a more clear sense of how you are going to look at it. Okay.